Welcome, everyone. We're going to give everyone a few minutes to log in before we get started. All right, I think that's enough time. We got people joining us. Everyone else can catch up as they come in. So thanks for joining us, everyone. In this episode, we're going to talk about software vendor risk. So, we're going to build on elements that we've talked about in previous episodes to build to this. We'll do a quick review, and we have some diagrams to explain sort of the whole supply chain life cycle and how this element fits on top of everything we've talked about previously. don't worry about the slides. Some of the charts are a little, the workflow diagrams are a little complicated. We're going to send everyone a copy of the slide deck out. So you'll get this, all the notes, everything. So you should be okay. But we're going to move on, get some of the housekeeping stuff taken care of. So obviously this webinar is going to be recorded. You'll get that link as well. Attendees who couldn't make it will have that link and they can watch this later on. We do have the chat open. So feel free to ask questions during. We'll pick them up at the end, or, we can stop and answer questions in the middle if something important comes up. There will be a poll at the end. They are always polls, but this really helps me figure out what content resonates with you guys. That's what matters to me most, right? These are educational. This whole series is about teaching. So as long as you're learning something, then it's worth the time. Reversing Labs is we're a growing company. We have about 300 employees. We're based out of Zagreb, Croatia. We have offices in Massachusetts. We have employees and customers all around the world, though, like most companies. This is me. I've been in security for a long time, and I've done some stuff. And now let's get into the good stuff. So, like we talked about, uncovering software vendor risk is really another way to build on this information that we have, using static binary analysis to recursively unpack all these packages down to the atomic elements, then do all the scanning on those and give you a detailed report of what's in your software. Right? This is, like an X-ray machine into software, where before all these packages were a black box. You couldn't tell what it was doing. Maybe you could do some vulnerability scanning, run it in a dynamic sandbox to see what it did, which doesn't really work well with software because it's generally software requires user interaction for it to kick off an action. So normally it'll just sit there until a user does something. So it doesn't really work well in a dynamic sandbox. That's better for malware and stuff. So we're going to use that same data set and build on it to find out, okay, now that we can see deep into this package, now we can see the, looking beyond just malware and vulnerabilities, which obviously, top priorities, but there's a ton of new information that we have from network communications, knowing what protocols that package has the ability to talk on, how it can connect, where it's going to try and connect to, behaviors, what can it perform, what data is it collecting on your system, your users, what other things can it do, and then does that align with what you expect from a package? It's supposed to do whatever. So based on that context and knowing that what you want to use this for, do the behaviors match up with that? Or is it doing things like extensive data collection beyond what it should be doing? So all of those things help you assess the risk of the package itself. And that's mostly what we've been talking about up till now. Last episode, episode 9, we talked about leveraging that data for a higher level function, like working with the SOC, right? You're already doing this analysis. You're already going to connect an SBOM or whatever your purpose is for this type of tool and this type of data. There's more you can do with it besides just looking at that package. So like last episode, we talked about taking the same information and leveraging that and helping your SOC avoid false positives, improve detections, and going from just doing a risk assessment and having a score to actually taking action using the information that you have now. This is going to be sort of the second part of that. We're going to talk about how you can assess the vendor itself using the same information. So just going through the software design lifecycle from cradle to grave here. Here's a couple of charts. So, ideally what you want to do is make this part of your workflow, right? So doing this type of assessment should be part of your purchasing, right? Do that risk assessment, look at that software and see what it's doing. Look at several versions of it, right? It's hard to do this stuff in a vacuum. It's a lot of information coming at you, especially if you're new to this kind of thing. So just looking at one package doesn't really help you. There's no context, right? And that's always the thing in security is data without context is just data, right? You want information. So you need that context. You need to be able to tell, okay, what's going on here and what is normal. So when you're doing a software purchase, you can assess these kind of things. And what you want to do is not just look at one version, right? If you have 3 options for software from 3 different vendors doing the same thing, you don't want to just look at one version from each and compare those, right? You want to try and get two previous versions too. So then you'll get these differential reports and you can see the changes between the two. And that sort of gives you a sense of how that product is being improved. Does every new feature come with a bunch of new vulnerabilities or other issues? And do they get remediated over time? Or does that number just slowly tick up over releases? So even just a trend across 3 releases is enough to give you a sense of how that package itself is managed, where the focus is. If the focus is on just pushing stuff out, or is it really on security? So you can see in the data whether or not security is important to that vendor. And that's what we're going to talk about today, is doing that same process, but doing it focused on vendors and less about the actual package itself. The second stage is you've done that assessment before you make that purchase, or you're assessing software you're already using. Once you've done that assessment, you know what the behaviors are, you know what network communications are going to occur, and you know which of those elements that you feel are risky. Now, with that information, you can hand that over to your SOC and work with them to then mitigate some of these risks. You can say, hey, we can tell that this software is going to communicate with these 10 URLs. Most of them are for, updates or whatever. And there's 2 of them that we think are sketchy, and we want to block those. So you make sure you allow what's necessary, and you can start blocking things that aren't. This is really important in EDR solutions because those are behavior based as well. So if you know this, this application is going to run scripts, it's going to run PowerShell or whatever, you let your SOC know, then they can filter that out from those detections and avoid a ton of false positives, save a ton of work. So you're, adding resources basically from the same work you're already doing. So it's just getting value multiple different ways out of the work you're already going to do when you're collecting your SBOM. And then monitoring is just the final step in that. And then we talked a little bit about that in differential reports. Again, one of the episodes we talked about earlier, episode 1, talking about 3CX, is really focused on that differential reporting and how to focus on the changes between one version and the next to narrow the scope of your analysis and look at just those changes and then follow that pattern over time. So these are the kind of things you want to do end to end. And it's the same process. You're just using the same information, the same assessment you've already made, and applying it in different ways. So we're not going to touch on behaviors, but we have talked about it. And I just want to show a couple of examples of what you can expect and what kind of behaviors you'll see in these reporting. So you can search for protocols. You can see the ones in highlighted in yellow are outputs where I search for specific things. So you may see, remote desktop all over the place. And this is, again, where you assess that package. Should it be doing this kind of thing? Do we expect this to connect to other devices? Do we expect other devices to connect to this? Is it a server? Is it an application on a workstation? And then do these things that you're seeing in the behaviors align with that? And if there's anything that doesn't look right, especially from one release to the next, then you can go back to the vendor and say specifically, hey, this thing started, should it be doing that? And again, these releases over time, if something doesn't look right, you don't push the release. There's generally, you're missing a few features for an extra week or 2. That the potential savings from a disaster are definitely worth that. Ask the vendor and go to them with specific details. This is what we saw in the report. Why did this happen? So let's look at a few samples here. So these are open source examples of how to walk through these reports. And again, like we talked about, when you're assessing a package, you want 2 or 3 versions of that package to see that trend. When you're assessing a vendor, whether it's, a larger partnership, you're looking to expand beyond one product to multiple products from the same vendor, or it's a new vendor you want to check out. Maybe it's a startup and they have 2 or 3 different things and you're looking into it. When you want to know what's going on with a package, you look at 2 or 3 versions and look at the trends across that. When you're looking at a vendor, it's the same thing. You want to look for a couple of versions of 2 or 3 different applications that they sell, and you're looking for patterns across the whole thing. That'll sort of give you a sense of what their focus is as a company and, the leadership and how they're driving that. Do the development teams have the right tools, the right resources to focus on security? Or again, like we talked about before in that package, or if every new release comes with additional risks, additional vulnerabilities, additional issues, or strange behaviors that pop up over time, do these get remediated? The things that make it through to this final package, which is what you're looking at here, tell you something about the vendor. And if the same things show up across multiple product lines, then that gives you a sense of what that vendor's about. Everyone's going to talk about security, but you can see here the proof. And over a couple of releases, do those issues tack up? do you see a ton of vulnerabilities in here? And over every release, they never get remediated. So then, it becomes an issue of whether the vendor has the right tooling to see these issues, or they do have the right tooling and they're just not going to spend the time and the effort and the resources to fix them. Either way, that tells you something about that vendor. So this is, again, the same analysis, but we're going to look at different components and weight them a little bit differently when you're looking at the vendors. So here's the overview of this report. And what we do is we have these policies set, and that's what drives this pass fail thing. So there's 170 or so policies. You can tune this to however you want. Now, this is an out of the box policy. There's a lot of things in here that cover a broad set of use cases. Your use case may be different. Your TPRM use case for this kind of thing will be different. So you're going to want to turn a lot of these things off and maybe turn a few things on that are important to you. But you tune the policy set to get the reporting that you want that shows you the things that are important to you. That's, the whole point. So we can see, by raw counts, and this is what we were used to, is just having these raw counts. So there's X number of issues. And then the next version maybe has X minus 2. But you really can't get a sense of whether they matter to you or not. So that's extra detail helps. And what we do here is we bucket these into different maturity levels. So you can get a quick sense between the number of vulnerabilities, the number of components to give you a sense of what builds this up, how the vulnerabilities are spread, how many criticals versus lows. All of these things are important, but here, this gives you an order of sense of what the maturity of this product line is. So level 1 is the most critical stuff: malware, tampering, source code leaks, that kind of stuff. So really, if you see a vendor and you're paying for a product and it has these kinds of issues in it, I definitely would question that. And then the scale of it as well. So level 2, again, another high severity level stuff is patch mandated CVEs. And you see a lot of code signing issues in here, or key leaks. So this, again, this could be bad, but we're going to dig into this a little bit and quickly show you how to find out whether or not it matters from a vendor perspective. But this gives you a sense of the maturity of the product. And again, over time, if you run 2 or 3 of these, you should start seeing these tick down release after release, or you should want to see them weighted towards the higher end, where they're sort of nice to haves and best practice stuff. We're down here, level 1 and level 2, right? If you can't make it to level 2, then I question whether or not I want your software on my network. So looking at these things, we may have some level 2 issues, and we know they have some code signing abuses. So look at the bill of materials. And this is a good place to start. So here, this is Wireshark. We see this. Now, I look at all the publishers. What I'm going to do is, for the bill of materials and for all the elements we look at, you want to look for the things that are related to the vendor. So their code, not third-party code, right? That's important for the package as a whole, but I want to see what the vendor does with their code and how they treat their stuff, and are there vulnerabilities and issues with the code that they're releasing, which then, if they're releasing poor code and they're not following best practices, then they're probably not updating their third-party packages and doing the other things that matter too. So in this case, there's a couple, right? Wireshark. They have one thing in common, so let's just search for Wireshark. And now I can see there are 27 components that are tied to this vendor. And now I can assess what the issues are. We can look and see what the problems are. So the executable itself has a couple of issues here, but they're medium and low, right? So the vendor code does have issues, and all code has issues. But as long as they're lower, then that's not as bad. So I'm not as concerned, but you're looking at things like best practices, where, when you see issues like this, it's a medium. But if the fix is just a setting in your IDE, or the lack of a tool or something early in the process, that tells you something about that vendor and their tooling. And if you see those same issues across multiple product lines, then you have to question their commitment to security and best practices. So all these things give you a sense of what that vendor's about, right? The proof is right here. So looking through this, we're not too bad, right? There's a couple of issues, but they're not huge. But this is, so you're looking at the same data as before, but now we want to just see, you're narrowing the focus to just the vendor stuff, because their code is what they should really care about, and it should be clean and pristine. If it's not, then you should have some concerns. So we'll go to the issues tab, right? And we bucket all the issues that you've seen up here, right? All these high, medium, and lows. Now they're bucketed by category, to just give you a sense of the breakdown. So for a vendor, what we're really going to look for is digital signatures, vulnerabilities in their code versus third-party code, and the mitigations that are in place. So mitigations are really just coding best practices. And we want to see, are they following those best practices where they control the code, right? Issues in third-party code, there may be nothing they can do about that. But, you know, if you take your code seriously, then I can take you seriously. So again, we had a lot. So I just want to see the high. I want to see what the worst elements are and get a sense of the pattern here. So we have pointer hijacking issues, which again is a toolchain issue. More hijack issues. Again, it's going to be another toolchain issue. So when you see these patterns of multiple issues related to tooling, that should be a red flag, especially if you see that same things across products. That means they don't have the right tools in place, the right visibility, or they're not spending the time and the resources necessary to release secure code. So all these things help you assess that vendor. Vulnerabilities are the same way. Again, it's not so much the count, although that does take some, that goes in the equation. But here we want to just see where those vulnerabilities lie. And we can see all these things here. These are third-party app components. So all the vulnerabilities are in other software that are dependencies inside this package or pieces of the package they're using from open source or whatever. That's a good sign. I don't want to see any of these in the vendor code. So that's good. Now, how they mitigate these is another factor, but that's weighted differently than their own code having issues. Same thing with signatures. This is another episode we talk about file rot, where you do see some of these components they're used in here that are really old, right? They get 7, 8 years old. You're always going to see some stuff. You're always going to see some expired certificates. It's just the way the world works. And if they're only a year or two, that's fine. What happens is when you see these third-party elements that expired years ago, that means that code, those pieces of code are written before that, a year, maybe 2 before that. So now you're looking at elements in here from Microsoft that are 9 years old. Now, in this case, I don't think there are any significant issues here. But when you start getting that old, best practices evolve. And those old code elements, they're not going to have new mitigations, new things in place to prevent new risks or new types of attacks. So these are all sort of these slow burn issues, right? Where over time, the risk is going to escalate. And if there are a lot of these things in the code, then you have to question that vendor, because these are things they should be catching, they should be looking at. So this isn't too bad. And also, when you get some of these older ones, 7, 8 years old, you also have to worry about really significant updates to coding best practices, where cryptography libraries have been deprecated because they don't have enough bits and they're too easy to crack. But if you have these older code elements, you may still be using some of those old things. So those are all things to consider when you're looking at this. It's, you're painting a broad brush and a wider picture of the vendor. And all these little things give you clues to that. We're not going to get into the behaviors and the networking. We've talked about that before. And some of the previous versions I mentioned in the earlier slide, you can go back and look at those and get a sense of that stuff. So let's look at another package, right? So here we saw, significant amount of issues for a file that's only 70 megs and lower level issues too, which isn't great, but there weren't a lot in the vendor area. So that's not too bad. So look at another one, right? This is a crypto wallet. Again, it's open source, but this one's pretty good. And for a crypto wallet, I would expect that, right? So again, you weight the application, the type of application it is. If it's just a simple notepad thing, as long as there's no malware and significant vulns in it, I don't really care about some of the other stuff. But crypto wallet, right? This is a financial thing, you want to put some money into this. I want this to be at least a level 3. And we've seen some of these, we did an episode on crypto wallets, and we've seen a lot that have, level 1, level 2 issues in here. So we'll go through the same thing. Let's look at the bill of materials. And there's nothing clearly that points out this vendor. So sometimes you do a little bit of research. Search for the vendors, but it looks like they're using a lot of third-party code. Let's look at the signatures and see if they sign any of their own stuff. Yep. So they do sign some of theirs. This is their certificate, their code. It's expired, but it's only 2 years. That's acceptable range. When it starts getting older than that, I'd question that with the vendor. And then we can see in the information behind that what issues may be in there. So again, ASLR, that's address randomization. That's been around since Windows XP. To not have this is a coding issue. That tells you something about their tooling and how seriously they take security. So all these things come into play to paint that wider picture. So this is actually not too bad. The vulnerabilities, let's again look and see where they're at. And looks like they're all third-party elements. Yep. And you get used to seeing this. If you do more and more packages, you start seeing the same things over and over. zlib is in just about everything. JPEG is, you see a lot, but you see all these third, and you get a sense of, okay, really quickly you can tell. And if there's something you don't recognize, then that may be vendor code. You may click on that and do some research. So sometimes you have to dig a little bit deeper, go to the internet, look some stuff up, but it all makes sense, and it doesn't take too long to do this, right? So it's almost silly not to be doing these things because you're already assessing the packages. If you're already doing risk assessments and SBOMs, you have all the information you need to do this part too. So looking through that, no issues and vulnerabilities. Now let's look at the coding best practices and the mitigations, right? Are they following best practices in their code? Well, take a look at this. And again, we see pointer hijacking, right? That's a tool chain issue. Depth, that's another old mitigation issue in here. So missing this, again, it's another tool chain issue. So you don't want to see these kind of things because these are simple fixes, right? If the IDEs you're using, if you're using professional tools, they should have these settings built in. That means you're just not monitoring your own code. That's a cause for concern. So we look at these issues that are related to this, and this is their wallet, this is their executable, and here's all the issues that are related. And there's some highs, but again, these are all toolchain related. So, maybe I look for a new wallet because while there's no smoking gun here now, I can tell that they're not doing this. That there's some basic things that they're not following in their own code. That's a risk. That may not be bad now, but in a year from now, it may be worse, and they're just going to keep adding up. So it's all stuff you have to be careful of. And then over time, we talk the first episode for 3CX, we talk about differential reporting. So let me show you what this looks like. So when you add all this stuff up, it's not really a ton of work, and the outcomes can be really important. So this is 3CX, right? Hopefully we're familiar with that supply chain attack that hit them earlier this year. So this is what this differential reporting looks like. And this is that ongoing monitoring, right? That third diagram that we showed earlier is that over time, every new release, you want to scan that and assess the risk. Are there every release, do we see new vulnerabilities? Do the counts tick up? Are we seeing them fix mitigations? Do we see, over time, sure, they have a big release, they put a bunch of new features in, maybe you see those numbers tick up, but every release after that, you should see them whittling away, knock 2 or 3 off here, 2 or 3 there. You should see that, that ebb and flow. But if they're not fixing this and they don't have the right tools and they can't see these problems, then those numbers are just going to tick up over time. In a year, 2 years, you're looking for a way to get hit. The more things that are in that package and the more places that package is on your network, the more vulnerable you are, right? It's just greater attack surface. So here, when we're looking at this package from a perspective like just the application, then this is clear. We can see that this is, when they had their attack, this is the last good release they put out, right? So we had this sort of baseline over time as it had so many issues and they were in these 2 categories. But now this first infected release, you can clearly see that something went wrong. And now you have to dig down and do the investigation. So now you can compare the 2 issues and see, okay, what changed? All right, we have evidence of tampering, we have evidence of malware in here. So now full stop, right? You don't have to know what's going on. You don't have to have the answers to all these things, but I'm not pushing this update. And this is it. It's this easy to see some of these things. You just have to be able to look. That's all. So over time, that's what you're looking when you're doing that package assessment. When you're doing a vendor assessment, I prefer to look at the raw numbers. It's how many issues are in here in each category. So over time, this was their initial baseline. It was 9 and 7 and 1. So for a few releases before that, that's where it was. Then all of a sudden it ticks up, and now something changed and you have to investigate that. This third release was a beta release that was like a week after the first one. And that's when their attack started hitting the news. We knew that there was a problem. And this is their first fix. So they fixed it pretty quickly as soon as they knew. And I thought overall, again, another thing to look at for your vendors is how do they respond to an attack? And to me, that's the real sign of what that company's about, what their leadership values, and how seriously they take the security of their customers. So if they just pulled that code out, right? So here we see that that beta release had issues, right? Same thing. It had malware, and we had that tampering issue, which is where the malware was hidden, a signed package. They remove it in this next episode. So now we're back here. This next release is a clean release, and we're back to the same 971. And this is where that vendor assessment comes in. And this is what I look at when I'm looking at these vendors. And this is why you want to do multiple packages across multiple product lines to get this sort of sense of the trending. So what happens is after that release was clear and they removed that malicious code, it wasn't business as usual for 3CX. And this is the thing that matters. And it's clear here that after that release, they got everything stabilized, but they continued to work. They went through and revamped their code. And I've looked at this pattern across a couple different, applications that they put out. And the pattern is the same across all of them, is they kept working. They put time, effort, and resources to go through their code, clean everything up, make it more secure. And you can see the results right here. Their latest version is, look at they have 2 serious issues in here and some medium ones. They had an attack. It could happen to anybody, right? What your assessment is and what your takeaway from these is, what do they do afterwards? Do they just remove the code and just keep on going and you don't see any? That tells you that leadership doesn't really care. They're worried about the PR issues and standing in front of a camera and talking about that. But as soon as they can get through that news cycle, they're back to the way they were. But you can clearly see here, they've added new tooling. They've taken a lot of time to redo their code. So to me, this is the kind of vendor I want to work with, right? Don't talk about security, show me. And that's why doing these reports, you have that data. You can answer that question and you can tell which vendors are serious and which ones aren't. So we'll go back to the slides here real quick. And again, this is just for your takeaway. So you guys have this slide and some of the comments and all the write-ups in here. There's detailed information in these slides. So hopefully they're valuable, beyond just this recording. But this is the highlight, right? When you're doing application monitoring, you're looking at different things than you are when you're doing a risk assessment for the whole vendor, where, the change here and the significant issues are, new things coming in from one release to another is where you want to focus on. But when you're doing the vendor, it's the trending stuff that matters, is what do we see over time? How do we see them fixing and taking care of their issues? So hopefully this was helpful. If you guys have any questions, please drop them in the chat. And I really recommend this whole series is supposed to be educational, right? There's no fluff. Go back and look at some of these things, but this is static analysis, this binary static analysis, which isn't reverse engineering. You're not going to violate a EULA doing this kind of stuff, right? That this is the perfect sweet spot for this kind of assessment. Is it gives you enough detail. You can dig down deep to get file level details where you need it to tell whether something's a problem or not. In a package, you may detect URLs going to GitHub. That's a detection we have in here. Now, is that in, something that's an executable or a DLL, or is it in a README file, right? So that issue can be caught, but the severity of that issue and the impact depends on where it sits. So you can dig down that path, but really you can do a lot of this just from the high level, right? If you're doing the diffs, if you're scanning every package, then all you have to do is look at the changes, and they're generally not that significant. And if you watch that, over time, you get a really good sense of what you expect from one release to the next, how many changes, how many different things, how often do they put in new stuff. And you can watch those counts and that trend over time. And that really tells you more about that vendor than just about anything else you can see. I trust the data and I trust the numbers. I don't trust, what people say. So I really do hope this was helpful. Don't we got any questions here. So unless you have anything, you guys will get a follow-up email. You have a link to the recording. You have the slides. And, please, go back and watch some of the older episodes and join us in the future. We're going to build and do more of these complex things and more analysis in the future. Oh, great. I think we're just in time. So we're available. If you have any questions, you can reach out and contact us. The tool we showed you here is SSCS. It's a core product for supply chain from us. We do free trials. That information we sent to you guys as well. So, if you're interested in this, you want to learn more, you want to poke around some packages and sign up for the free 2-week trial and run some of your own software and, see what you think, get a feel for the information, the data that's available. All right. Thank you all for joining us. Have a good week, everyone.